to take this opportunity to welcome everybody to our webinar. And today we're going to be talking about the foundation of the electromechanical workflow. In this case, we're going to be talking about um, how do you associate your footprints in the library editor to 3D models. And we have multiple ways of doing that. But before we do that, let's do some introductions. First of all, my name is Edwin Robledo. I'm part of the Autodesk support team, and I specialize in Eagle, and I'm here located in South Florida. I've been working with Eagle for a very long time. I'm actually part of the original support team that was actually acquired by Autodesk. And with me today is Jorge Garcia. Hey, Jorge, why don't you say hi?
Hi, everyone. Nice to see you today. I was also part of that CADsoft team that came over with the acquisition. Been working with it for close to 10 years, and I'm happy to have you all here as we go over this very important fundamental topic of libraries.
Excellent. Thanks, Jorge. As you can see, my little spinning badge there that I used for that class I was telling you earlier as well. Also, so today we're going to talk about the foundation of electromechanical workflow. In this case, I'm going to talk about our libraries. So the importance of libraries, the building blocks of every electronic design is based on accessing components that will be used in the design. Libraries are the key of this. Good set of libraries are the core of any good electronic design. The designer can easily find the parts that they require. The designer can quickly and easily compare parts to enable them to choose which ones are need to use most appropriately. Quickly access information about the parts, meaning links to data sheets, descriptions. Also, assigning attributes and accurately assigning 3D models. Now, in Eagle, it has a library structure. The library editor has a basic structure, and the structure actually consists of 3 editors. The 3 editors are the schematic symbol editor, the footprint editor, and it ends at the device editor. And they all work together. And I'm going to explain all these 3 stages real quickly. Since the majority of you are very experienced with Eagle, I want to run through this quickly. The schematic symbol editor is a logical representation of an actual physical component. Basically, it consists of pins, which represents each pad. Each pin has a function and a name. Remember, this is only a representation of the component. We strongly suggest that you create the schematic symbol on a 0.1 inch grid. Do not deviate from there. You define the variables for the name and the value and any additional attributes that you may consider using for your internal use. After the schematic symbol, you're going to create what's called a footprint. This is going to be based on the physical aspects of that component from the manufacturer. You're going to be taking into consideration the measurements of the pads, the distance between the pads, also referred as the lead spacing, the measurements of the physical spacing between the rows of the pads as well, the dimension of the body of the component as well, and you're going to be putting all that together. Okay. Now you're going to put it all together in something called a device. You're going to be calling on the schematic symbol. You're going to be calling in the schematic, the package, or the footprint, and you're going to be associating each one of those pins to one of the pads. Once you put it all together, that is called a device. Okay. Now you have a device. Now, once you have a whole bunch of devices in one file, we refer that as a library. Okay. Once you use these devices in a schematic, you no longer are dependent of that library, because every time you use the device in your schematic, the entire component information, the association between the schematic symbol and the footprint is carried over to the schematic. So you no longer depend on the library. So as soon as you work with that schematic and that board, it knows exactly how to associate, and all the information that is necessary is there. The library is no longer dependent. Now, let's talk about associating 3D models to our footprints. Before I go there, I need to introduce something called library.io. Autodesk created a system called library.io. It's a website, but it's a lot more than a website. Library.io is a fundamental resource that provides a parametric ECAD, MCAD content generation online. It allows you to upload step models. It works with Eagle to sustain 3D models by means of managed libraries. It allows you to access your managed libraries remotely. Autodesk Eagle is able to provide library updates. And let's see how the managed library works with Eagle. So Eagle is actually working with library.io. Let's see how this works. First of all, oops, having trouble going to my next slide. Okay, very well. Now, in the library editor, you're going to create a managed library. When you want to actually assign 3D models to your components, you need to create a managed library. And what this means is that your local library is now going to have a duplicate on the cloud. And that cloud is called library.io. It's the exact same library, but it's on the cloud. Okay? It's the exact same library. You have your local library and you have your cloud library, and they're synchronized. Okay? They're totally synchronized. What happens is that your local library cannot support the 3D model locally. It is actually sitting on the cloud. But Eagle is actually able to visualize, the 3D model by means of actually tying to the 3D model by means of a unique random number, a URN number, and actually is able to tie the footprint and the 3D model and associating it that way. And that association will remain there as long as the libraries are synchronized, the local library and the cloud-based library. And that's how you create a managed library. As you can see on my screen in the bottom left corner, in the library editor, you have library and you create your managed library. And if you notice, I created kind of a screen there of how it gets synchronized, your local library and your cloud library. How do you think about my little screen there, George? You think I kind of did it? You think my representation there kind of how I synchronize my libraries there? You think that works there? What do you guys think that
I think you did it justice.
Yeah, you think it works? My local library and my library.io,
Yeah, that works.
You think it works there? Okay, very well. That was my intention. I was kind of trying to figure out how I visually represent my local library synchronized with my library.io cloud-based library. So I was trying to do there. Okay, very well. Now, once my library is managed, now I have multiple options to assign 3D models to my footprints. And let's go through those now. Okay, once I create my managed library and my table of content, you'll notice that in the table of content in Eagle, you have a column called 3D packages, and you can see that right there. I'm pointing with my yellow arrow. When your library is not managed, you'll see that the column is empty. When your library is managed, you'll see that the column actually has content. But the content, when you highlight it, the 3D models has like these packages. They're like these gray boxes. Now we need to start adding 3D models to these packages. We need to start assigning 3D models to it. And there's 3 ways of doing this. Okay. And I'm going to go through each one of these ways right now. Okay. Let's do this now. One way is to associate a step model to my footprint. Remember, you already have a footprint. So if you have a step model, you could associate a step model to your footprint. In this example, I actually asked a Fusion expert. Fusion, just to let you know, Fusion 360 is actually a mechanical application by Autodesk. And I asked we asked one of the engineers from Fusion 360 to create this pot for us. Jorge asked them, and I just used it for this example. And so Jorge had made the footprint, and I used it to associate that step model to this footprint. And you click on the button there, upload step, and I associate it to this step model. So one way is to upload a step model to a footprint. And that's one way. Another way is that library.io, which I'm accessing from within Eagle. Okay, I'm accessing library.io from within Eagle. Library.io already has several thousands of 3D models in its repository. So I could actually select one of the 3D models that are already available which I can associate to my footprint already. So there's very common components like resistors, capacitors, DILs, DIPs, QFNs that I could already associate to my components. There's thousands of parts already available. So I could add a model from the repository that is available. Or I could use the generator, the package generator that comes with Eagle. It started only as an IPC package generator, and it still is, but we've taken it to the next level because it's doing a lot more than just IPC compliant parts. It's doing a lot more. I'm actually doing a header here as well. I could actually use footprints that are in Eagle, and I actually use the package generator to create an associated here. But I could actually use the generator to create the footprint and the 3D model as well, which Jorge is going to demonstrate as well. So there's 3 ways of creating models associated to my footprint. I hope this clarifies exactly what I'm trying to demonstrate here, how easy it is to associate 3D models. And I'm going to let it go from here. I'm going to let Jorge go ahead and take over from this point on. I can see it now, George.
Okay, cool. So let's go ahead and start with an empty library. First thing I'm going to do is save it. Let me make sure I'm online. I'm just noticing it's going to get in the way. Online. Here we go. So now we go back to our library. So now let's go ahead and save it. Call it webinar 01/24/2019, which is today's date. Okay, now first one we're going to make is just using the package generator. And when you use a package generator, you can have 3D inside an unmanaged library. This is the only situation, or the only one of 2 situations in which you can have 3D in a non-managed library. So one is if you directly use from the package generator, if you use it. The other way to do it is if you copy from a managed library into a non-managed library, the 3D model will come with it. So those are the 2 ways to get 3D in unmanaged libraries. Either use the package generator or copy from a managed library.
Okay, let's slow down there a little bit. Okay, hang on. So, okay, slow down.
Slow down.
So my slides were all about creating a managed library.
I know.
What Jorge is explaining here is that it is possible to have 3D models in your library without having a managed library. And that is possible by copying a footprint that has an associated 3D model between libraries, and the 3D model will copy along. That is possible. And that works. Okay. Also, you could use the package generator and create a footprint and a 3D model, and that library does not have to be managed either. Is that what you're saying, Jorge?
That's right. That is what I'm saying.
That's what he's trying to say. I hope if you didn't understand that, let me know. Okay. And of course, the question is how to copy between libraries, and we'll get to that.
We'll get there.
We'll get there, Chris. Okay. And we try to do these within 30 minutes, but we don't mind going over. Okay. I hope we'll try our best to stay within 30 minutes, but we don't mind going over, Chris. Okay.
Mm-hmm.
So just hang with us.
So let's go into the package generator and let's make something. Let's go ahead and make a
So
part.
this first example is using the package generator without using a managed library.
Correct. So I'm going to go ahead and click on QFP because the part I want to make today is this one. This is the STM32LO52 family.
And today's webinar, we're just making footprints and 3D models. We're not going to really go into symbols and devices.
Right.
Okay. We're only working with footprints and 3D models. Okay.
Correct. So right now the package I'm interested in is the LQFP 32-pin version. So right now we go through the table of contents. Every data sheet's a little bit different. There's no standardized way. Every company kind of sets them up however they feel makes the most sense. But usually you can find some sort of link to the package information. And here we are. Okay, so I clicked on that link. It took me to page 128. And now we can see all of the numbers for the recommended footprint and how we can use them. So let's go ahead and go back to Eagle to the library. We're going to pick a QFP. The pins on each side are going to be 8 by 8 because this is a 32. You have 4 sides. They are symmetrical. So we go 8, 8 over here. We can specify the pad shape, whether we want a rectangle, rounded rectangle, or oblong. We'll see the differences once we start updating the preview. Now, we're going to look and we see that we have different letters that correspond to different sections of the image over here. One thing that's extremely important is that when you look at the data sheet, you need to map these to the ones in the package generator. What does that mean? What it means is that the manufacturer doesn't always follow IPC conventions when defining these. A lot of these will be okay. They may be close to standard if they're not spot on standard, but you're going to get some extra ones sometimes that don't map or that map differently. So you need to always take a look at the picture and make sure that you're matching to what's in Eagle's package generator. So let's look at an example here. So first off, let's look at B. B here defines the pin widths.
The width of the pad.
Correct. Well, the width of the pin. The pad is calculated automatically based on the IPC standard and our density level, which we'll talk about once we update the preview. So, and then we can see that E here is the pitch. So let's look at those two quantities, pitch and the pin thickness. So we go over here to the data sheet. Let's see. Okay, B matches. B is definitely the pin width. And E matches as well. So we don't have to do anything funny there. We're okay. So now we can go to the data sheet, find the appropriate values, and put them in. So let's go ahead and do that. So
notice that there's always like a min and a maximum, okay, guys?
Mm-hmm.
There's always a min and a max.
So here for E, you'll notice that we don't have a min and a max. So in those situations, what you would want to do is you would want to go with typical if one is provided. So we can see here that for E, we get 0.8. Okay, and that's what's provided. So we go back to the calculator. Okay. And then for the thickness, lowercase b, we have them right here. We have a minimum and a max. So again, we go to datasheet, B, 0.3, 0.45. So let's go ahead and put those in. .45. Okay. Now we're going to do the rest in order. So let's look at D here. D and E are the overall dimensions, including the length of the pins. Let's see if that matches up with what our data sheet specifies. So we look over here and we see that that is the case. D covers this length and E covers this length. So far this manufacturer is following IPC specifications. So far we're good. So we'll go with D, 8.8, 9.2. 8, 9.2, and E should be the same. Let's confirm that. 8.8, 9.2, we're good there. So all we're doing is just reading off values from the data sheet. L, let's see what this is on the data sheet. So we go over here. L. Where's L? Okay, matches as well, so we're good there. 0.45 to 0.75.
This is a lot easier than just making the part from scratch the old school way, you know?
Oh, for sure.
A lot more math had to go into making it the other way.
Whoops. 0.45, 0.75. Okay, the B, we already got. D1 and E1, let's check. So we want to get these, D1, E1, let's check. We go over here. We see D1 again is still matching. D1, E1 is also still matching, so we're okay. And these, we checked, they should be the same, and they are. 6.8, 7.2. 6.8, 7.2. Okay, we're almost there. We just got to get the A, which is the height of the part, and then this little A1. So let's go to the data sheet. Whoops. A. Okay, we got the A. It does match, and the A1 matches as well. So in this case, they followed the IPC to the T. Don't assume that will always be the case.
Yeah, they did a really good job at trying their best to use those criterias, but you know, don't
assume.
You don't assume it is.
So I'm putting that in 1.6, and then the A1 is 0.05, 2.15. Change that. All right. Awesome. So at this point, we'll go ahead and leave the rest alone. We'll do an update preview. And there we are. Awesome. That means I didn't screw up any of the numbers. So that's cool.
Just to let you know the white dot, you know what that means. Pretty sure I don't have to explain that.
But just in case, white dot is pin 1. Wherever the white dot is, that's pin 1, and then you go around counterclockwise. Okay, and that's just a convention in the electronics industry. You start with pin 1, and then you go around counterclockwise, increasing the numbers. So at this point, let's talk about a couple of other features that we could use. So thermal pad, this component does not have a thermal pad. As a microcontroller, it's not a power component. But if you ever needed it, you can define it. Let me go ahead and turn off the board view so we can kind of see from the bottom. Okay, we can see all the pads. If I turn on thermal pad and I do an update preview, you'll see that you get this crazy big thermal pad. Okay. Again, we would adjust it on something like this. It'd probably be more like 5. Okay, but that's not the case for this part that we're making, so we wouldn't use it. So I'm going to go ahead and uncheck this. I'll update the preview. The other thing we want to note here is what the heck does this density level thing mean? Okay, so the IPC defines pad sizes depending on density level. So if you're going to have a really, really tight layout, it could be the case that you can't afford for the pads to really extend that much. You need them to be tighter. So in that situation, you go from nominal, which is normal, you go to least, and let's observe what happens to these pads, okay? Really keep a close eye on these. Okay, and you'll notice they shrunk very considerably. They're really tight around the pins. Placement's going to have to be perfect. But on a really dense layout, you may need that. Okay, so that's least. Obviously, most is the opposite of that. You know, maybe you're going to solder by hand. You want to try to make your life as easy as possible. You may pick most. And again, look at the pads. Keep an eye on what's going to happen when I update this. You'll see they get longer. They get even a little bit wider. Okay, but this is all based on what your manufacturing considerations are. So most of the time, if you don't have a preference or if you don't have a requirement, you can stick with nominal. Nominal will give you a good result. Pad shape is pretty self-explanatory, but let's try out rounded rectangle. You'll see how they got kind of mitered on the sides. And we can try oblong. And you get these that get like the half circle.
Is this just a visual preference? Is there any actual electrical reason behind any of these, Jorge? Do you know?
I don't think there's an electrical reason. I do think there's a manufacturing yield reason. Some board houses prefer one versus the other. But in most cases, it doesn't seem to make a big difference.
I thought there would be maybe a routing preference, to be honest with you.
But again, you know, I could be wrong on that. So if anybody does know, feel free to share it in the comments. That way we all learn.
Yeah, awesome.
So I'll go ahead and finish this. Now, when I finish this, we're going to get both the 3D model, which we've made, and the footprint that comes with it. So I'll say OK.
Now, remember, we're accessing library.io through Eagle. So this is a cloud-based process with which has an interface through Eagle, through the library editor. Okay.
Correct. Now, in newer versions of Eagle, there's very little reason to go to library.io these days. You can pretty much do everything from within Eagle. So that makes it a lot easier. You don't have to go and open up your web browser and go to library.io. Library.io is still useful if you want to like clean up, if you want to like destroy, you know, libraries that you don't need anymore and stuff like that. But most of the workflow can actually be done from within Eagle, and that's what we recommend nowadays. So
yeah, you could actually clean up from the control panel now. Your managed library. I was testing that the other day.
But it'll delete it on the cloud? Or
yeah, it will actually prompt you. You want to delete your local copy, or your local copy and your cloud copy will actually prompt you.
Oh, sweet.
Yeah, it will actually prompt you. Yep.
Excellent. So you can basically do everything from Eagle now.
You could do it from Eagle. Yep.
Okay, and that's likely how most of us here would want to work.
Yep.
So we'll go ahead now and move on to another scenario. So we're going to go ahead and make a footprint.
Yeah, the thumbnail, as you can see, has a little gear there. It just takes a little while to load. It's creating the thumbnail because it doesn't load the actual 3D model, the step that it's creating. It's building a thumbnail, and eventually that thumbnail will show up. So that gear will be replaced with a thumbnail eventually.
So what we're going to do now is we're going to build a little crystal. Okay, something that can't really be made. This type of crystal can't really be made by the package generator. It can make other crystals, but not this one. So let me go ahead and show you guys. This is the crystal that we are referring to. This is a little reflowable tuning fork style crystal. Here is its recommended land pattern. Now I've already gone ahead and done the little bit of math that this requires to have it centered. You don't have to center your footprints when you make them, but we very, very highly recommend doing so. That'll guarantee that the handle's in the center of the part, so it's always easy to grab. So not a requirement, but a really, really strong recommendation. So let's go ahead and we're going to go ahead and build this one. Okay, what's nice about the dimensions that they've made here is it's really easy to figure out the individual pad sizes. The only thing that's a little bit tricky is that they don't reference anything to center of the part. So we kind of have to calculate it based on the extremes. So that's the only thing that's a little bit hairy about this one. But overall, figuring out the pads is pretty easy. So let's go ahead and go to the library editor and do that. Okay, so I've gone ahead and made a footprint, AB26TRQ. We're going to click on the SMD command. Now, notice that the SMD command, you can specify individual sizes. You can also use the SMD array option. So this is really handy. If your footprint is generic enough, you can create the whole thing using this. So we definitely recommend you check it out depending on what you're making. For this particular crystal, this is also not going to be helpful because it doesn't quite mold to this type of template. So we will be using the sizes.
And it's available for the symbol as well, just to let you know.
Yes, it is available for the symbol as well. And there it's really, really useful.
Mm-hmm.
So I'm going to put my grid in metric because that's the units we're working in. I'm going to put in the size of this one. We're going to make the big pad that was on the left first. So that one is 2.4 by 1.5 millimeters. So I press enter. Okay. So now I want to place it. This one, in order to have the part centered, is going to be at, and we're going to put this in the command line. So Control L, command line is active. So this one's going to be at negative 3.45, 0. Okay, there's that. And now we're going to put in the sizes of the two small pads.
If you have any questions about the command line thing that we're doing, just let me know, okay?
Mm-hmm. Yes, please let us know.
So when you click on the pad command or on the SMD command, on the parameter toolbar, actually you could see where Jorge's icon, Jorge's mouse cursor is. Right to the left of it, you see like a little pad with a thunderbolt right there. That's the pad array. That is. Let me know if you could see that, Chris. Jorge, can you? He wants to see where the pad array is
Oh,
at.
where the pad array is at? Sure.
Yeah. He didn't see it.
Okay.
It's that little thunderbolt there.
This one right there.
Yeah,
right there.
That's it. That's the array.
Right there.
Okay,
That's the one I'm hovering over.
And the symbol looks exactly the same way. When you run it in the schematic symbol, it looks exactly the same way.
Okay, so I think I've actually made
when you activate the pin command, you're going to see it there on the parameter toolbar. So the very first toolbar you see on the top, we refer to that as the action toolbar. The second one below that is called the parameter toolbar. That's the one that changes when you activate commands. And that one is, always look at that one when you activate anything. When you activate any command, always check that one out because there's always really cool options, okay?
Mm-hmm. So
I know our experienced users know that one well, but for anybody that's new, always check that one out.
So we have the other little ones. Those are 1.1 by 0.6, and that's just reading it off the data sheet. So we can look. Okay, I'm just reading it off of there. 1.01 by 0.6. Okay. So one thing that I did notice, I did make originally a mistake in my calculation, so we'll fix it now. Oops, not that. Brought up Slack. Okay, so now we go over here.
I just got the best question.
Yeah?
Yeah.
I'm sure it's a good doozy.
Can we use the keyboard for our commands? Absolutely, yes.
Yes.
You have a command line, you could type in all of your commands, or you could use the assign command to assign every command to a keyboard, to a key. Absolutely.
That's right. This one should be over here too. There we go.
We define the site between pads. How? Not sure I understand that question.
The separation here?
He says how we define the site between pads. Not sure what he means site.
I think it means size.
Oh, how, okay. How we define the site between pads. Not sure. Oh, because he used that, because what he did is that he actually defined the X and Y coordinates
Of where the pad needs to
of
be.
the pad, correct. Since he typed in the X and Y coordinate of each pad, he didn't have to use the grid.
Yeah.
That was the so he typed in the X and Y coordinate of one pad and the X and Y coordinate of the other pad. It did regardless of the grid, and that's why that happened.
Mm-hmm.
That's just to let you know.
Yep, and as we can see, that's it for the crystal. Let's take a look. So that you guys know, what I'm doing is basically the center line is through the middle of the big pad. And because Eagle references the pads by their center, the Y is 0 because I'm going through the center of the pad. I'm using that as my reference. And what I had to figure out is what's the X location of this pad. So the way I did that is I added these these three measurements, 2.4, 3.8, 1.1. That gives you 7.3. You divide it by 2 to figure out the distance from the center of the part. That gives you 3.65. So then all I have to do to figure out is where this pad goes is I subtract half of its width from 3.65. So basically 3.65 minus 1.2, that gives you 2.45. And that's on the left of what the imaginary center would be. So it's negative 2.45. That's where this one should be. And then for these, I did something similar. I took 3.65 for the X dimension and subtracted half of the pad width since they have to be placed on the center. And that gave me the location for this. The vertical separation is pretty easy because, again, we're going through the center. So we know that half of 0.3 goes to each side, which is 0.15. And then we add half of the pad's height to get the Y location.
And this is because, remember, the handle of the pad is the dead center of the pad, okay? Mm-hmm. The handle of the pad is the dead center. So that's why you have to calculate the math that way, okay?
Yeah. Okay, and this allows us to make a footprint. So the only thing I'm going to do to kind of finish it off a little bit is just, I'm going to put in...
You going to change the grid?
I'm going to change the grid to like something like this.
Did we answer your question, Cristiano? Are you okay? Did we answer your question? I just want to make sure we got I want to make sure we answered his question.
Mm-hmm.
Now what we're doing now is that we're just adding some silt screen for the body, and the silt screen for the component body is always drawn on a layer called a T-place layer, just to let you know.
Mm-hmm.
So he's drawing some line using the line command on the T-place layer.
Yeah, it's just to have something there to indicate where the body should go. And then the other thing we want to do, let me go ahead and just I'll name this one ground and leave these like this, or just 1 and 2. So this would be 2, this would be 1. Again, counterclockwise. Okay, the only thing missing from the footprint to be complete, really, from the minimum requirement would be the name and value text. And there's a really nice way to put those in. There's a UOP that comes with Eagle. UOPs are little scripts that are C-like that we use to automate certain functions. So there's one that comes with Eagle called set name value. Pass it right here. Okay, you double click it and it automatically puts in those texts for you. We can just move them around and there we go. Okay, awesome. If you want to put in more detail, you totally could. Definitely description is an area where you can make your life very easy just by putting in links to the data sheet, maybe even a picture of the component, because the description is HTML compatible. It covers a good amount of HTML's functionality. So you can put in links, you can put in different text heights and things like that. Very, very useful. But for a bare minimum, to actually be able to use the part, this is what you need. So we're going to go table of contents view, and you'll see the footprint there. Now, at this point, in order to be able to assign a 3D model to this, we do have to make the library managed. Okay, because remember, there's only two ways you can put 3D content in an unmanaged library, either through the package generator or copying from an existing managed library. But that's not the case here, so we need to make this library managed. So we're going to go library. I'm going to say create managed library. Got to save it. We say yes. You're going to get this window. Now, what do we want to keep in mind about this window? There's one very important thing to note, and it's this checkbox. Okay? And this is something that can create confusion, so Ed, we may have to talk about this a couple of times now.
Let's do it. Yeah, that's an extremely good idea. Yeah, especially I want this on the, we need this on the recording. People understand this on the recording.
When you make your library managed, okay, what ends up happening is it's not that the local library gets updated or upgraded to some other status. Rather, what we do is we take the local library, we relocate it after we have pushed it to the cloud, and then from the cloud we download it again so that it's a managed library. So the original library, the original one that you made managed, that one gets moved to this location that's specified here. Okay, see users.
And this is archive. That's just a backup.
Yeah, it's just a backup.
It's just a backup.
Okay. So when you make a library managed, what's going to happen is Eagle makes a copy of it to the cloud, takes the original that's on your computer, moves it to this new location, and then downloads the copy, the cloud version. And that becomes the managed library that you're working on locally. Okay? When it downloads that cloud version, that gets saved to an internal location. That way it's protected because it has a lot of links and things like that. You don't really want to be messing with the internals of that file.
It doesn't really want you to know where it's at either. I mean, you have access to it through Eagle.
Right.
But it doesn't really want you to know where it is, but you manipulate it through Eagle.
Correct. And the way you manipulate it is in the control panel. You go to libraries, managed libraries, my managed libraries. And that's where it's going to show up after we go through this process. Mm-hmm. If for whatever reason you don't want to have the library archived, you don't want to have Eagle relocated to the location here, you uncheck that box. Okay? And Eagle will leave it where it is. So if you have the library saved with your project, it's going to be there. Doing that can be confusing because if you start modifying that one, you're not doing anything to the cloud version. You're not managing, you're not doing anything to the managed version.
I recommend keeping it checked.
Yeah.
Because if not, you're going to make changes to this library, your managed library is going to fall behind and you're not going to sure what happened with what.
Yeah, and that's where this can sometimes be confusing. So let's do a quick recap because again, this is important and we want to make sure that it's okay. Normally, by default, when you make a managed library, the local library gets copied to the cloud, it gets relocated to the archive location, and then Eagle downloads the managed library. That managed library is going to be accessible from the control panel under Libraries, Managed Libraries, My Managed Libraries. Okay, that's where you're going to be able to grab it and work from it. The original is just going to be archived. You don't need to touch the original anymore. You can just work off the managed library. Now you get the benefits of having it stored on the cloud, so you can work on any computer. Doesn't matter where. In the near future, once we have the ability to share these, you're going to be able to share them with teammates using Eagle. So you won't have to do weird server locations and things like that anymore.
Also, if you go to any other computer, log in with your account, you call out the managed library and you could access your managed libraries, just to let you know. Okay, you don't have to carry your libraries on a thumb drive. You don't have to email them. You don't have to put them on Dropbox or anything like that. Okay, just to let you know. I just want to reiterate that. Once they're managed, they're there. Once you log into your account, they're there. Okay.
All right. So now I'm going to click Create. And I'm sure the chat just blew up with a whole bunch of questions about what we just said.
Okay, yeah. So So let me, well, this is, oh, wow. Oh,
Yeah.
it's a small library. It went really
Yeah,
fast.
of course.
I was going to answer some questions. Usually it takes a little longer.
All right. So now we've turned this into a managed library. I'm going to click OK. And what you're going to see is at the top, it tells you that it's managed. And it gives you a version number. So if you're ever in doubt, you just look at the top. Does it say a version number and the word managed? If it does, it's a managed library. If it doesn't, then you may be working with the original version that either wasn't archived or that you went and you opened from the archive location. Okay? So once you manage library, you only want to work with the managed version. You only ever want to see this. So now at this point, you notice that I do have a 3D package for this one now. Okay?
It was empty earlier.
Okay, our
Oh,
footprint
the
finally came in.
footprint caught up. Yeah, your footprint caught up.
This one gets this, but it's not going to have anything right now. So what we want to do now is we want to edit this 3D package. We want to assign it a model. So I'm going to double click it. And you're going to notice that by default, if no 3D model is assigned, you will get a rectangle that corresponds to the maximum dimensions of your footprint. Okay? And that's what we have here. We have this giant rectangle of doom. Now, if for whatever reason you have a part that's like a fiducial or just pads, and you don't want to have a 3D model, you just don't want the rectangle, or you don't want anything at all. You just
Might
want
be a
to leave
test
the
point or something like that. Yeah.
right. If that's the case, the workaround for now is to set all of these to 0. Okay? That's the workaround for now. So you just delete all these. Zero and 0. Okay? And you okay that, and you'll see that you'll have a footprint whose 3D model is nothing. Okay, and that's the workaround for now. We'll have cleaner ways to deal with this in the near future. We do have a few tickets open for that. Okay, so now we want to get it back. I just clicked on resize to copper. We have it back. We want to now assign a model to it. So there's many ways you can do it. Again, from here you can run the generator. You can add a model from library.io, which we'll be showing next, or you can upload a step from the manufacturer. You have to have downloaded the step model from before. This doesn't link directly to any manufacturer. You have to go to the manufacturer's website, get the step model, and then you can upload it through here. So I'm going to go to my downloads.
That would be kind of nice if we did.
That would be epic.
Yeah, that would be kind of nice.
But it would also become a monster.
Yeah, exactly. Yeah.
So I'm going to pick this one.
And just to let you know, many manufacturers actually provide the step model of their components, just to let you know.
Yeah.
And actually, some distributors do too.
Yep. There we go. So it did upload. However, the way it uploaded is obviously not too correct, as you can see here.
Oops.
Okay, but this is easy to fix. So you can actually freehand it. Just turn it. It'll actually pause at every 90-degree increment. You can raise it up. And right here, I got to rotate it. I actually have it 180.
Yeah, exactly. Yeah, you gotta
pop. Okay, now we go.
There you go.
It's still a little low.
I think you got to bring it up a tad.
Yep.
There you go.
And obviously, this is me freehanding it. You know. You could also tell whoever made this, you know, didn't design it such that it would lie flat. They just kind of took whatever measurements there were and put it in like that. But well, that's okay.
You know, but the idea for this is when you use this on a mechanical application, you want to make sure that you don't have collision. So it does the job. You know?
Yeah. It definitely covers that use case.
Mm-hmm.
Now, if you needed to be more specific, you can obviously type in values here. But the freehand tools in this setup are actually really nice because you can do whatever main rotations you got to do, and you can still move freehand in a really reasonable way. So usually you can just freehand it to get the model to look the way you want. Okay, any questions on this one?
No, not yet. But could we pause here for a minute to
Of
answer a
course.
couple of questions I
Do
had?
it.
You know, so hey, Chris, yeah, you are correct. If you have large components, it does get a little complicated. That's why we have the pad array and the pin array, and we also have another. Uh, we were talking about something called ULPs. We have something called make package symbol and device, which creates components as well for more complicated components. But the package generator really solves a good portion of components, and that's why we have it. Yes, Sean. Yeah, you're talking about the greater sign name. Yep. And we use a ULP now for that. I had an occasion to add a part using older method, manual creation, assigning a 3D model. I haven't tried. Oh, okay, good. Okay, so if you are offline, you cannot access the managed library if you are offline. So the question is accessing the managed library if you are offline.
You have to
Actually, you can access the managed library if you are
already,
offline,
but you
but
had to have already downloaded it.
yeah, you so so you have to have already downloaded the managed library offline.
Online.
Online, yeah. So you've downloaded the library. In other words, you can have not had the library first. So you need to have the library. You could use it now. You cannot do the whole 3D thing now. So in other words, you will not be seeing the like if you export a step file from Eagle, you're not going to be seeing the 3D models with it. You're going to
Well,
be seeing square boxes most probably
well, you won't be able to because all of our 3D conversion in some
are going to
way
be on the cloud.
hits up the
So
cloud. Yeah.
yeah, so you'll see that everything in 2D will be perfect.
Mhm.
But in 3D, you're not going to see anything because all the 3D functionalities of Eagle are cloud-based. So yes, you will be able to use the library as long as you've downloaded the managed library first. Okay. And let me see. This is from a custom library that is managed. A 3D name doesn't seem to be generated. The 3D name doesn't seem to be generated. Even a generic pad such as Jorge is showing. I'm not really sure I understand that. Even the generic pad such as Jorge is showing. Yeah, no, the pad it's just the landing. Remember, it's just the 2D. Yeah, the pad itself is not 3D. That's just the landing on the board.
Yeah.
Yeah, that's not really 3D. It's the body of the component is what we're really is the 3D part.
Yeah. So in the case of working on the train, you could download the managed library before you get on the train, and you would be able to work with Eagle and do your PCB and stuff, but you wouldn't be able to generate a 3D model on the train unless the train gave you Wi-Fi.
Yeah, and actually, if you're in Europe, the majority of them do. The majority of them do, actually, if you're in Europe. I can build my footprint and symbol, but get no option for 3D model.
Okay, so when that happens, that would mean that you either haven't made the library managed. Okay, so you have to make the library managed in order to get the option. As soon as you do, then you get the name of the same name as the package. The same name as the footprint showing up in the 3D package column, and then you can assign it. So that could be what's going on, Sean.
Okay. Now, the last example is using the repository.
Okay, so let me save this one.
Yeah.
I'm going to dock to bottom. There we go. Okay, notice checkbox here, provide version description with saving package. Always provide version information. Always.
On your 3D model, the z-axis says 0.95 millimeters, but the part is 1.45 millimeters.
You want to look up? No. That's the location above of the reference point for the part. So if you look, this reference point I think is in the middle of the part. So let me cancel this real quick. If you look, the reference point is at the center here, so it's at half the height of half the width. So it's the height of the reference point relative to the board. So it's 0.95 millimeters, that reference point. So if we look at the data sheet, link over here, data sheet it's 1.4, half of 1.4 is 0.7. So it could be 0.95 because it's going to the center. See how it's going to the center of the 3D model? So from here to the bottom edge of the model itself is 0.7.
And then the rest is the
is a 0.25.
Mm-hmm.
Okay, is that clear? So at this point, I'll okay this. Always put in something for the description. Okay, so I'll put uploaded, whoops, step model. Okay, we'll say okay. And there we go. You'll see 3D packages updating. Again, you won't get the thumbnail. Thumbnail takes a little while to produce. So now the last thing we want to do is we're going to go ahead and copy from another library and then assign a 3D model to that. That's what we're going to do.
Don't you have to push a new version?
I should push a new version, yes. So actually I save. Once you, because I hadn't saved my changes. So once you save, you're going to see that you get this appear. Version 1 plus edits. Whenever you see plus edits, that just lets you know that you haven't pushed to the cloud. There are changes that have been made locally that have not been pushed to the cloud. If for some reason you don't tend to look up here, you'll notice that the icon here at the bottom becomes blue. Let me, the stupid thing is getting in the way, the bar. It's not showing it. But right here, this little thing, that's a blue box that says D for draft. And that lets you know that you have some edits in the local version that haven't been pushed to the cloud. So we can push them to the cloud just by going library, create new version. And you'll see we have some other options here. You can discard the local edits, you can update to the latest versions on the cloud, or you can create a new version. We're going to create a new version. We'll say okay, it's creating. And boom, we're at version 2. Okay. And we can see that it's come in, even though
Oh, that's pretty fast.
Yeah, angle's a little weird, but it's there. Okay.
Yeah, I created that thumbnail pretty fast.
So as you make changes, and if you want to keep the cloud version in sync, you have to do that. You have to create new versions and push to the cloud. So now let's bring in a component from another library. I'm going to go here, add device. The process I'm going to show you works the same for the others. So for symbol, if you want to import, copy a symbol from another library or footprint, it all works the same way. When you do a device, you'll see that you can write a name or you can click import. I'm going to go ahead and grab from my George library that I have. Actually, no, from this one, DC load. I'm going to grab this. It already has a 3D model associated to it, but I'm going to associate another one. So we'll say OK. And when you import a device, you get everything that's associated to that device. So every footprint, all the symbols.
Hang on, wait a minute. You went so fast. Okay. You went so fast, guys. I got to stop Jorge sometimes. He just goes so fast. Okay, did you guys see that? Okay, so what he did is he clicked on Add Device, but instead of creating a device, he clicked on the Import button. That way he could actually get a device from a different library. And I know Chris had asked about how do I get devices from other libraries or components from other libraries. And somebody else had asked me about that earlier today. So the way
this is how.
And this is how you could do it. And you could do this for symbols, devices, and footprints. Okay? So the way you do it is that you click on Add Device, don't give it a name, and click on Import. And then this will look at all the libraries which are in the library path, and then now you could actually search or look at the library trees, select this device that you're looking for or the symbol of the device, and then import that. Okay, let's go ahead and now you could get, because some other people had asked me about this. And there's another way I'm going to show you before Jorge does it, to do it from the control panel as well, which is even easier, I feel. Okay, go ahead, Jorge. I needed to stop you because you blew through that. You blew through that, and I needed to stop you on that one.
Time out. That's what you gotta do. Just call it. Okay. So again, this one already comes with the 3D package associated to it. We can double click it. Okay. You'll see that the model is there. We have the option to just remove it, which I'll do right now. And when you do that, it'll basically replace it with this rectangle. We can resize it to copper. So that way it's limited to the copper dimensions. And then at this point, so just to go back, you can remove the model. There'll be a button here that says remove model. At that point, you get the rectangle. And now we can go ahead and, if we want to, we can upload a step model. We can generate one using the package generator, or we can add a model from library.io's resources. And again, library.io has many, 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 many models.
Thousands and thousands and thousands.
So you have the option of just looking through your personal models. Okay, so everything I've ever uploaded is here. Or
You've been busy, George.
you can go to all models and see everything that we have. And there's a lot.
So that's a combination of what Jorge has been working on plus what the developers and the team has been uploading.
Yeah. So we can go over here and just type in whatever we want to search for, because it won't show you everything in this little preview thing. It takes a while to load all that up. So just do search for S.
And you could change the view in the little screen there on the left. You could do it through lists or through icons.
Correct. This one right here?
Yeah, right there. You could change the view if you wanted to as well.
Okay.
Give it a minute.
If not, maybe I'm missing the dash. Did I hit enter?
I don't know.
No, I didn't. Okay, let's do a...
Get rid of the 8.
There we go. We'll put that. Sort by name. Okay, we get that. Oh, I used a 0 instead of
instead of a O.
Yeah. Sorry, guys. There we go. So I can go with that, and I just click add. And now here, just have to rotate it, and I'll pretty much nail it. Okay, and this will be local to this library, okay? So it's that easy. It's just searching and not putting zeros instead of O's. That's a big deal. Okay, any questions about this?
No, not right now. No, that was easy. And you know, and also, yeah, go ahead and finish it off, Jorge. Also, in a library, if you have a device which is already associated to a package, just to let you know, you could use the replace command and replace it with a package variant that has a 3D model. I actually use that quite often.
Yeah.
I've actually imported a footprint that already has a 3D model from a different library, and then I replace it with that one in the device editor as well. So, so hey Jorge, let me do a favor for Chris really quick. Could you go to the Eagle control panel really quick?
Show him the drag and drop way?
Yeah, not the drag and drop way, but just right click a device and just show them the copy to library really quick. So Cristiano, if you want to copy something from a library to your own library, what you do is that from the Eagle control panel, find that part, have your library open, just right click that component and just select copy to your library, and that's it. Now, somebody stated that you have something on the download library. What you could do is that you need to have the download folder as part of your path in Eagle. That's one way to go about it. Or
Yeah.
have that library in use. One or
Hmm.
the other one. You have to put that library in use, or have it in. Well, first of all, it has to be in your path and in use, both of them.
Hmm.
It has to be one of them. That takes care of that. So as you could see there, Jorge expand the library, and he has a library open up in the background. And as you could see there, you could do a right click and just copy library. Or if he actually had the library open side by side, he actually can just drag and drop into his library, and that would work as well. I've
Yeah.
do that really easy.
I'm trying. Yeah, I'm trying. I gotta try to minimize this a little bit to get that to work. So let's do
Are
this.
you on Windows 10? You should be able to kind of like
I'm on Windows 7, man.
there's a way of easily putting them side by. I can't remember
Yeah,
how.
as you told me. I think
I
it's is it
I
hold the
think
Windows
you
key?
hit the for pane and the arrow. I think
Oh,
it is, isn't it?
I don't remember.
It's something like that. I don't remember
So
exactly.
yes, you can just drag it. You can go like this and drag it over into here,
Yeah.
and you'll see it'll come over,
So you could drag and drop as well.
which is very cool. But it can be hard depending on your monitor setup. So you just right click, copy the library. The key thing is to have the library you want to copy into open. That's the key thing with that.
Okay. Are the standard libraries according to IPC spec?
The standard libraries that ship with Eagle are not. They've been made over, what is it, 25 years?
Yeah, plus tax.
Plus tax.
Yeah.
So they're not
Not
IPC.
necessarily. No, not
Yeah, not
necessarily.
necessarily. They are made to whatever the manufacturer specified, but if the manufacturer wasn't IPC compliant at that point in time,
Mhm.
then no.
Okay. Also, this is great, but it doesn't allow libraries to. Okay, yeah. Jumping back to the crystal design, the part seemed to be floating above the pad.
Mhm.
The reason it was floating was because you entered the width of the component instead of the thickness. It was a bit thicker than it was wide, just for your information. Okay.
Oh, so was it? Hold up, that's interesting.
That was from Dan.
Jumping back, the parts seem to be floating above the pad. The reason it was floating was because you entered the width of the component instead of the thickness. Ah, let me see. Dan may get me. Let's take a
Yeah,
look.
I think Dan is on spot. Yeah.
Dan is on the spot.
Yeah, Dan is on the
1.48.
spot. Yeah, yeah, he's right. Yeah.
You're the man, Dan.
Yeah, Dan got it. Yeah. Thank you, Dan. Appreciate it. Yeah, we got the best users, man. Yeah, we got the best users. Yeah. Um, download. Okay. One last question. Okay. Yeah, go ahead.
Yeah, it's
You
many.
could ask whatever questions you guys want, man. We're here. It's all about Q&A. Yeah. Well, the presentation. We have anything else to go?
No, we're good.
No. Yeah, we presented everything we wanted to present so far. I have a problem with my microcontroller step model. I use the Aqua A5. I try to use the step model allowed by manufacturer to don't work. It's so big, I think.
Okay, so with that, Cristiano, okay, what can happen there if you upload the step and you see that Eagle does this thing, I'm processing whatever, and then it looks like it did it, but you don't see anything? What can happen sometimes is that whoever made the model drew it off in space somewhere, so it's not anywhere near the step model's origin. It's actually off in space. What you can do there.
Yeah, there's a couple of tricks you could do there. You might want to show that on the screen,
That's
George.
what I'm going to do right now.
Yeah, it's happened to me a couple of times. Like, where the heck is the part? I'm hoping that's what it is.
Yeah, I think that's what it is.
Yeah, I'm pretty sure. Yeah.
Okay, so sometimes you see how the origin of this part was in the center over here, the center of this area. Sometimes the person that drew the part, for whatever reason, I've seen it happen, somebody maybe who wasn't paying attention to what the origin of the drawing is. The origin of the drawing will be here, but the model will be off in space somewhere. So what can happen is if you go ahead and you look out, sometimes you have to like zoom out a little bit and look around, and you may find it, floating off in space somewhere. The other thing you can do to try to make that better is if you go to options, there's model centroid and footprint centroid. If you use model centroid, what I think it does is it looks at the objects in the model and tries to find the center of mass. So even if they're drawn off in space somewhere, because all of the drawn objects are off in space, it'll center to that, and you'll be able to grab it. So usually these will help in finding a model that just doesn't seem to show up for some
Yeah,
reason.
use either one or both.
Yeah, play
Yeah,
with it.
until you find it. Yeah, and it will show up right on the center of the board, and sometimes it will actually even line them up. It all depends on how the component was made. Um, I had one that I had no idea where it was, and I was in the middle of a demo. I was in the middle of a demo, and the gentleman had provided us the step, and I actually highlighted both, and I found it, and so it worked out really well.
Oh,
So,
okay. He says it's not that.
oh,
Yeah, for sure. We're gonna put in the support email now at
yeah,
the
yeah,
end,
yeah. Let me put
and
it
you
in.
can just go ahead and send it.
Yeah, I'll just do it right now. Support.eagle@autodesk.com. Yeah, send it to us, man.
Yeah, our developers always like to run into things that cause a break because then they can see, what they need to do to improve that.
Yeah,
So,
you're right, Sean. It might be out of scale. Yeah, it's quite possible as well. Yeah, you shoot it out to us. It might be a bad step model. It just might be a bad step file. Yeah, always go check GrabCAD. GrabCAD.
GrabCAD.
Yeah, go check out GrabCAD, but see if they have it as well. See if they have it as well. Usually, what I do when I have any issues with a step file,
Mm-hmm.
first thing I go is I try it in Fusion 360, so make sure if it's good,
Mm-hmm.
and then if it is, and then I export it in Step again from Fusion,
Yeah.
see if it cleans it up. Oh, careful
Yeah.
with that one.
Yeah. Yeah. Well, Sean can type that. We can't.
Yeah, exactly. I can't go there. I can't go there. Yeah, I'll let Sean do that one.
Yeah.
Agma Systems Agua Step. Okay. Yeah.
Okay. Thanks, Cristiano, for sending it.
Okay. Okay. Cool. Yeah, send the email, Chris. That'll be great. If
Yeah.
there's no other questions, I greatly appreciate it. We covered a lot of information here. We went over a lot of the time that we wanted to, but really wanted to go into detail in this area because we wanted to cover that you push the fusion and you get square boxes. We wanted to go over that. And there's a lot and we didn't cover everything, to be honest with you, all scenarios,
Yeah.
but the most common scenarios we wanted to be able to cover. And remember that from Eagle, you also could export the step
Mm.
file, and this takes care of step files as well. And if you joined us on last Tuesday, which we can now talk to Fusion Team, we have that third extension now, the Fusion Team. This is going to help you with Fusion Team as well. So if you're going to work on a collaborative platform and you want your boss or your team members to see your boards in a collaborative platform in 3D, this actually helps as well in that environment as well. So, once you map everything in 3D in the libraries, it just carries over to a whole bunch of other areas. So, and that's why I wanted to take this, and we're going to be doing this next month again. So if you missed it, don't worry about it. And I know it's a very long topic, but it's just we really want to go into detail in it. So we want to hopefully we covered all your questions, and we'll continue doing it. So thank you very much. Greatly appreciate it. Jorge, thanks for the demonstration. Great job as always. It's been always a pleasure. And all of you that have joined us, thank you for being here. Thanks for your patience. Thanks for your questions. Anything else comes up? I see Luli's posting some YouTube.
The Fusion Team webinar. She's posting it.
Oh, she posted that one.
I
Oh,
think she
okay.
posted it.
Oh, okay, cool. So, I guess I have to because we're only seeing it. Okay, so let me.
No, she sent it to all panelists. She got it.
Oh, but the users are not seeing it. Only us.
It went to all panelists.
Yeah, but that's us. We're the panelists.
Ah,
That's what I'm
dang
telling you. Let me copy paste.
there we go. No, Luda's got it. She fixed it.
Okay, put it to everybody. Okay, there you go. Okay, yeah.
All right, bye everyone.
Thank you, everybody. Greatly. That was awesome, man. It was a lot of fun as always. Thank you for being here. And hey, don't forget, the forums are always pretty active. We could always use your if you want to post any questions, and don't be shy. If you could help us out answering questions from other users, all of you are now experts. modeling in 3D. And so if there's anybody that has any questions, we'll use your help as well. We have now 25 new experts on mapping 3D models. So thank you, everybody, and have a great day.
Bye, everyone.
All right, thanks. Hey, Luli, nice to see you. Everybody, have a good one. Bye now. I lost the webinar link. I have so many screens open. Must have it somewhere around here.
You gotta tell Liz on that one to put most important thing when working with managed libraries, and just go to that little section, like a little, you know, on YouTube you can put like a little shortcut to a certain spot in the webinar to put our conversation about what happens when you manage a library.
Okay, okay. Yeah, I think it went really well. I'm still online. I haven't been able to find my Zoom page. Oh, there it is. Finally, I find it. Bye, guys. Okay, finally, I find my page. Okay.